The relationship between the side length, which is S, and the surface area, A, of a cube has a relationship in the form of A equals KS squared. So I've got here a table of values that compares S and A. Create a table of values comparing S squared and A. Graph the relationship between S squared and A. Figure out what is the gradient of the line, and that'll be the line from part B. And then write the equation for the relationship, A equals KS squared. So actually figure out what that value of K is going to be. So for part A, create a table of values comparing S squared and A. So I've got up here a table of values with S and A in it. So I'm going to take my S value, square it, and it turns into S squared. So 3 squared is 9. And I'm going to do the same thing with 7.5. So 7.5 squared is 56.25. Put that in the table of values. And we'll do the same thing for 12 and 20. I'll pull up a CAS now and show you how you can do this fairly quickly on here. So on the CAS, we're going to use a list and spreadsheet. I'll put in my X value, which I'll just call S for the side length, and the values that I'm asked, or that I'm given in the table of values are 3, 7.5, 12, and 20. Now I want another column for S squared, because that's what I'm being asked to create this table of values for. So it doesn't like me putting in a squared sign, so I'll just call it S2. And in the formula box, which we saw in the first example as well, you're going to put in, quite simply, S squared. If it was any other value of n, so S to the -2 or S to the -1 or S to the 3, you would do the same thing here, just change this value to whatever n is. Press enter. Again, we want our variable reference, and the calculation is done for us. We can fill in here our A value if you want, but that's the key part of that new table. Part B is now asking us to graph the relationship between S squared and A. So I've got that table that I created in part A, and I'm putting on a graph here. Now notice that my labels here, this is not going to be S, but this is going to be S squared. So these values here go along this axis. Before I just do that though, let's have a quick look at what S versus A looks like. So the original table of values that I was given looks a little something like that. So it's a very steep, not quite a straight line, but a curve that looks like that. If you look back at that table that I had that showed you the different values of n, this looks like it certainly could be n is 2. So I think we may be on the right track here. Just get rid of that. And we'll have a look at each of our points. So I'm graphing again here S squared versus A. So the first point, second point, third point, and then the fourth point, 400, 2400's way up there. Well, that looks like it's a straight line, which, as we said in the lesson, it should be. And we can have a look at this on the CAS as well. So just come with me and we'll try and do that. You can have a go at it yourself first. So I've just created another column here representing A, which is the area. And I've got my S squared versus A. So let's add a new page, data and statistics. And our two variables, we're going to compare S squared So those values up to 400 to A. That certainly looks like it is a straight line, which is what we want. So excellent. So part C asks us, what is the gradient of that line? Well, I've got points on the line, 954, 144, 864, etc. So just pick 2 points and calculate the gradient, just as we did in the very first lesson of this chapter. y2 minus y1 over x2 minus x1. So I've chosen these 2 points here, just because the numbers look a little bit easier. I don't want to have to deal with decimals anymore than I have to. Plug it in, simplify as best as I can, and 6. So the gradient is 6. I can also show you how to do this quite quickly on the CAS. So from this page, I've got this straight line. Well, we know how to calculate or figure out an equation of a line quickly on the CAS. They're all in a straight line. We can do something that we did way back at the beginning of the year when we were looking at linear regression. We can analyze this plot with a linear regression. I'm going to choose option 1, mx plus b. And I can see here that my gradient is 6. That is the gradient of the line through all of those points there. And last but not least, write the equation for the relationship. A equals k times s squared. So essentially this is asking us, what is k? Well, we said in the notes that k is the gradient. And we found our gradient of s squared versus a. We found that in part C. That was 6. So k is 6, and a equals 6s squared. That's the relationship between the side length and the surface area of a cube.